Hi, welcome back. It's question 2, and now we're differentiating, and there is your clue. So in this first part, differentiating x cubed times e to the power of 3x looks like the product rule. So one of these I'm going to call u, and the other one I'm going to call v. So I'll write those down. So u could be this, and v could be this. And for the product rule, I need to then differentiate both of those. So I'm going to use du dx, which is 3 times x squared, dv dx. This is actually using the chain rule itself, and that's going to be 3e to the power of 3x. And the rule for that is if you differentiate e to the power of any function, you're going to differentiate that power, multiply by it for e to the power of that function. And then the product rule says if you've got a product like this, then dy dx is u times dv dx plus v times du dx. So I'm going to do u times dv dx. So that's x cubed times 3e to the 3x plus v times du dx. So that's e to the power of 3x times 3x squared. I could write this slightly nicer and just put it like this. So I'd say 3x cubed e to the 3x plus 3x squared e to the 3x. If you wanted to, you can factor out 3 and e to the x or whatever you like, but you could leave it like that. So that is part I. Moving on to part II. This looks like a quotient. Okay, and the quotient rule is given to you in the formula book. And it looks like this. So if y is equal to something in that form, dy dx is given by that. So we're going to need to identify a u and a v, or in the formula book it uses f's and g's, so it doesn't really matter. So if I've got this, I'm going to call the top bit u, the bottom bit v. So u is this, and v is this. And again, I'm going to need to differentiate both of those, so I can use the formula. So du dx is 2, dv dx is minus sine x. Okay, putting that all together with the formula, this is where I do need to be careful. So this is a variation of the formula in the formula book. I could write this using u's and v's like this. So it would be v du dx minus u dv dx over v squared. So that's another way of writing it. So I'm going to do v times du dx, which is 2 times cos x, minus u times dv dx. So that's minus 2x sine x all over v squared, and v is cos x, so v squared is cos squared. And then I can write it like this: 2 cos x plus 2x sine x over cos squared x. And you can leave it like that. So that's part II. For part III, we're going to differentiate tan squared x. Now, tan squared x can be rewritten like this. And that looks a bit like chain rule. So whenever you've got brackets, it's usually the chain rule. So for the chain rule, I would say that bit in the brackets I'm going to call u. So I can define u as tan x, and therefore if I call this y, y is equal to u squared. Probably want to differentiate both of those again, so du dx is going to be sec squared. And if you don't remember that, that's actually in the formula book. Okay, so point for the formula book, that's going to be sec squared. So that's in the formula book as well. dy du is just 2u. Now the chain rule says that I can use both of those, so dy dx is going to be dy du times du dx. So I can just multiply these two together. So dy dx is dy du, which is 2u, times du dx, sec squared. But I need to write this in terms of x. I'm going to sub u back in, and u is just tan x, so it's going to be 2 tan x times sec squared x. That's part III. Part IV, or part 4, as we should say, says find dy dx in terms of y when x equals cos y squared. Just be careful, this is not cos squared y or cos y all squared, it's cos y squared, so it's just cos of y squared. Now to find dy dx, this isn't y equals something in terms of x, so it's probably better to find dx dy. Now how do you find dx dy? We'll differentiate with respect to y, and this looks like a little bit of chain rule again. So I would call your u this thing, because we can just put it in brackets. So u is going to be y squared, therefore x is equal to cos of u, and du dy is 2y, dx du is minus sine u. So we can just multiply those two together. So you get minus 2y sine u. U is just y squared. So we get that. So this is dx dy, but the question wanted you to find dy dx and in terms of y. So we can leave it in terms of y, and to find dy dx, we can just flip dx dy upside down, or reciprocate it. So dy dx is going to be 1 over all of that. If you like, you could just put the minus on the top. So it could look like that as well. As we probably should. So that's part 4.